All right, good afternoon. Welcome to Using AWS Lambda as a Security Team. I'm Brittany Doncaster. I'm a Solutions Architect at AWS. With me today, we have Sydney Sweeney. She's a Cloud Engineer from Dow Jones. And we also have Andrew Baird, Principal Solutions Architect at AWS as well. So here's our roadmap for today. This is our agenda, but really what we want you to get out of today, what we want you to take home with you, is we want you to take away from here when you have a problem, when you have a security control that you need to enforce or verify, when you have something as a security team that you need to accomplish, we want you to understand how Lambda can plug into that solution, where you can utilize it, and what services it integrates with easily from a security team perspective. So if you've been to an AWS security presentation before, you've probably heard us talk about get the humans away from the data. The further away your humans are from the data, the better, because you make your processes more automated, more repeatable, et cetera. But traditional security engineering is a very manual process. It's a lot of spreadsheets. It's a lot of policy documents. It's not a lot of automation. And so when you have very manual processes in order to enforce your security and verify your security, it really makes it almost impossible in order to have your humans away from your data because they have to be in there touching your production systems in order to verify the controls you put in place. So that's why we, as an organization, you'll hear us at AWS talk a lot about moving toward an automated security posture. So moving towards putting your controls and your policies into code instead of into spreadsheets and policy documents. But as you start to create these different code baselines, what you don't want to do is you don't want to have an added complexity to your operations, right? You don't want to just add to your problem of more things that you, as a security organization, have to worry about operating or worry about securing the underlying infrastructure that it's running on. And so you don't want to kind of multiply the additional infrastructure that you have to worry about. So the answer to this is AWS Lambda. AWS Lambda, if you're not familiar with it, is our serverless compute service. So for AWS Lambda, you don't have to manage any infrastructure. You bring your code. You tell us the triggering event that you want to have that code, when you want to have that code executed, and we will execute it for you. It's very cost efficient. You pay only for exactly the amount of time that your function is running. And again, you can bring your own code in many different languages that we support. So we support Node, Python, Java, C#, and we also support Go, which didn't make it into the slide. But as I stated before, you can actually set up the triggering event for your Lambda function, and we'll talk about different triggering events that will be important to use as a security team. So the first one we want to look at, the first kind of pattern we want to look at here is event-driven. And Amazon CloudWatch, if you've been on AWS for a while, you're familiar with Amazon CloudWatch as where you get your metrics about your AWS resources from. So where you see CPU utilization on your EC2 instances, things like that, right? But as it's evolved over the course of the last few years, it's added a lot of features and functionality that as a security team you can really take advantage of. So to dive into some of those components, we're going to look at the different features of CloudWatch that you want to be familiar with. So as I mentioned before, CloudWatch has the ability to aggregate a bunch of different metrics across your AWS resources, or it could be applications you have running in AWS, or it also could be applications you have running on-premise. So you can put CloudWatch agents running on your instances or your on-premise hosts, and you can aggregate and collect all of the metrics from your infrastructure and resources and send them into CloudWatch. You can do basic math on them once you have those metrics in CloudWatch. And then you can set up thresholds. And when you have thresholds set up, you can set up alarms based on those thresholds. So traditionally, this is how you would do auto-scaling. You would set up, maybe you wanted to auto-scale on CPU, for instance, and so you would set up a metric when my aggregate CPU gets above 60%. I want to set an alarm, and that alarm's action is going to be to scale out and add another server. One of the other actions that you can do besides auto-scaling based on CloudWatch alarms is that you can send a notification to an SNS topic. An SNS topic is one of the triggering mechanisms for AWS Lambda. So we'll get into different use cases for each of these integrations, but I just kind of want to point out the different components of CloudWatch. So again, first we have CloudWatch alarms based on metrics coming in that can send notifications to SNS and then trigger a Lambda function. And you can also integrate with other third-party tools that you as a security team are already probably used to using. Second, we have CloudWatch events. And CloudWatch events come in two different flavors. So the first flavor is time-based CloudWatch events, and these are really, they work on a schedule, right? So these, you can think of them as a cron job, right? You set up a schedule that you want them to execute on, and then when the event fires, then you can set up the action that you want it to take. One of those actions that it can take is it can call an AWS Lambda function. The other type of CloudWatch event is event-based. And this is a really powerful feature, and we're going to talk a lot more about how you can use CloudWatch events and the event-based CloudWatch events and as a security team. But really, this is close to real-time events of what is happening within your AWS account from an API actions perspective. All right, and the third piece that you want to be familiar with from CloudWatch is what we call CloudWatch logs. And this gives you the ability to actually aggregate all of your log information, your log data. And you can put filters on that log data. And then from those filters, you can then create subscriptions from those different AWS CloudWatch logs. And those subscriptions can then be streamed to different endpoints. And one of those endpoints, again, is AWS Lambda. You can also stream it to Kinesis or Elasticsearch. But today, we're going to be interested in AWS Lambda. So to recap here, the three different ways that you can integrate CloudWatch with Lambda that are going to be important to you as a security team are through CloudWatch alarms, through CloudWatch events, and through the CloudWatch logs. So the first one that we're going to look at is CloudWatch logs. AWS CloudTrail, if you're not familiar with it, is basically an audit log of everything that's happening within your AWS account. So any API call that is made within your AWS account, it creates a CloudTrail record, a log within the CloudTrail log. It creates a record within the CloudTrail log that you can then have streamed into Amazon CloudWatch logs. And then from there, you can execute a Lambda function. So again, you can, with this, you can actually create filters on these logs. So maybe you don't want to send all of the API data. Maybe you only want to look at API calls that are being made by the principal, the root user, right? And you want to set up some kind of alarms. Maybe you want to integrate with your existing tools, et cetera. The second log source that you want to be familiar with as a security team is VPC flow logs. So VPC flow logs you can think of as your NetFlow logs. These have source and destination IP. They have the ports that the data is going to, the packets and the bytes, or the backets, whatever. The packets and the bytes, and then it also has, the most important part of it is it has the accept or reject information. So based on your security group rules, based on your NACLs that you have set up for your VPC, was the traffic accepted or rejected into that Elastic Network interface? So what does this look like? When you have your, over on the left-hand side, you can see we have a CloudWatch log group. And you can choose that log group, and you can choose to stream it to AWS Lambda. At that point, you're creating a subscription to AWS Lambda. And you can specify, you can see the subscription filter pattern. So you can filter things out. So that's where you could filter out in your CloudTrail logs, things like the principal is root, or you could also send all of this data, for instance, with VPC flow logs, you could send all of that data to AWS Lambda, and you could actually decorate some of that log data before sending it on to your existing security tools. So the ENI is the piece that comes through, the Elastic Network Interface ID is the piece of information that comes through in a VPC flow log record, but it doesn't tell you what instance is associated to. So you could take that Lambda function, you can actually do some decorating of that log in order to have some additional context before it's sent out to your existing security tools, so that the person who's actually going to respond to the event that you're creating can have a lot of additional information about where they need to go and what instance has been affected, et cetera. Okay, so the second piece we're going to look at is the metrics. So I mentioned already that all of your AWS resources can send in, or some of them automatically send in metrics out of the box, right? EC2 will send in CPU, et cetera. And AWS WAF is one of those services that also sends in CloudWatch metrics out of the box. So as you create an AWS WAF rule and then create a web ACL out of that rule, it automatically creates a CloudWatch metric for you. And so from that metric, you can then, again, you can create thresholds, and then from those thresholds, you can create alarms. So this is kind of cool because well, we'll walk through an example a little bit, but every CloudWatch or every AWS WAF rule that you have gets then sent into a place where not only is it you're able to graph it and see all the different traffic that's coming into your WAF. You can see all the blocked requests, you can see all the allow requests based on individual rules or based on the aggregate rules that you have set up for that particular endpoint. But then you can also take actions on it. So we'll talk about some of the use cases for that in a second. And the other service that you would want to be familiar with is AWS Shield Advanced. So Shield Advanced is this is our managed DDoS protection service. And basically it gives you a binary CloudWatch metric that says, are you under attack from DDoS right now, or are you not? And you can obviously see the importance of what you might want to do with that information. You would probably want to alert someone. So if we look at the AWS WAF use case, here I have set up a WAF, a few different WAF rules, and I've combined them into a ACL that is applied to my API gateway endpoint. And so you can see I have a large body match rule, so it's looking for a request body that's too large for my endpoint. And then I also have a SQL injection rule. So if we take the SQL injection rule, for instance, you can see in the bottom right there is a little alarm bell, so you can click on that and you can create an alarm based on the SQL injection rule. And so here you can see I'm creating an alarm, I'm calling it a SQL injection alarm, and I'm setting my threshold to be greater than or equal to 5. So if I get more than or equal to 5 SQL injection attempts within the period of time, then I want it to send a notification to this SNS topic. And it creates my alarm. It sets it up, and it's not in an alarm state, so you can see the little green box around the metric on the right. And then I create an AWS Lambda function to actually subscribe to that SNS topic. And then in this case, it's not really doing anything. It's just really printing out the notifications so that we can see what that looks like. But there's a lot of different really cool things you could do with this. So when I actually send in a bunch of SQL injection requests into my API gateway, then it goes into alarm mode. And then you'll see these are actually the logs that are printed out by my AWS Lambda function. And so it's giving you a lot of really cool information here. But the important part to note, again, here in this example, all I did was print this out. But you could also go and take some automated remediation actions. You could go and obviously integrate into your existing tools like PagerDuty to have somebody come and look. You could do some more interesting things too, like maybe if it's X number of order of magnitude over your normal threshold, right? So somebody's really trying to knock at that door and knock down your defenses and get in. Maybe you want somebody to come and just check on the exterior boundary of your security defenses and make sure that everything looks good. And so you can kind of have that kind of smart alerting within your AWS Lambda function that you know you're being protected by the WAF, but if you start to see a really big spike in attacks, maybe you want somebody to just go and check it out. So again, there's a lot of different use cases for this. You could use it for alerting, remediation, and integrating with your third-party tools that you already have. OK, and the last piece, we have event-driven events, little redundant, yes. And with these, we have a few different security services within AWS that actually emit CloudWatch events, and they emit them as findings. And if any of you were in the keynote today or watching it, I'll talk a little bit at the end here about how this all comes together now that we have AWS Security Hub as well. But we have AWS Macie, or Amazon Macie, which is our service for securing and protecting your assets within Amazon S3. So what it does is it combines natural language processing with user behavior analytics, and so it understands what kind of data you're storing in S3 and then how that data is being accessed, and it combines that information in order to really know is your most critical data being accessed in an anomalous way. And so it can provide context to the alerts that it's giving you based on that. If your PII data is now being accessed anomalously, then it can create a high priority alert versus maybe you just have some configuration data that that's had some anomalous behavior. And then second, we have Amazon Guard Duty. So Amazon Guard Duty is it's an amazing service. If you don't have it turned on in all of your accounts, you definitely should. And it combines VPC flow logs, CloudTrail logs, and DNS resolution logs in order to create well, it sends those into machine learning models in order to understand what anomalous behavior and patterns are looking like for your account. So it learns for about 30 days or so, and then it starts to alert based on any anomalous behavior. But it also can protect you from other things like Bitcoin mining, remote access Trojans, et cetera. It has the ability to detect those types of things within your account, and it will send you findings based on those. And then finally, CloudTrail, we already talked about CloudTrail logs, but actually CloudTrail API activity, most of the CloudTrail records can actually be sent in an event-driven manner to CloudWatch events. The only ones you're not going to get events for are kind of the describe and list kind of APIs, but any APIs that change or modify your resources will come in as a CloudWatch event. And then what you can do is you can actually capture that event. So here we're capturing a guard duty finding, but you can also capture somebody deleting an EBS volume in a production account, for instance. You could capture somebody terminating an EC2 instance in a production account. You can capture deleting an S3 bucket policy, right? So somebody's trying to go in and change the bucket policies that you have for your S3 buckets. And one of the really cool things now with AWS Security Hub is that now you don't have to, a guard duty finding is a little bit different from a Macie finding. And the really cool thing now about AWS Security Hub is it's all going to have one common pattern or format for these findings that you can deal with. So you're only having to deal with one common format in order to figure out what to do with all the different findings that you're getting from your AWS security services. And they will come in as CloudWatch events as well. So you'll be able to create rules, CloudWatch event rules, to capture your AWS Security Hub findings and then take actions on them. So again, you can integrate those with your third-party tools. You can do automated remediation, forensics, countermeasures. And you can also do security automation. One of the really cool tools for security automation that again, as a security team, you should have in your back pocket is actually a service we have called AWS Step Functions. So as you're using Lambda, it's really meant to be these small microservices that do one thing. They can be reused, et cetera. And AWS Step Functions actually allows you to coordinate and orchestrate the calling of multiple AWS Lambda functions. So let's say, let's take a very simple example here of you want to do some automated remediation, but then you also want to send out a notification to someone in your security team that you did this automated remediation and then this action was taken. And so you could actually do those two things in parallel. You could do them in sequence. There's a lot of different options within AWS step functions. It's very easy to use. It's a very simple JSON format. And so you basically would say, call this Lambda function. And if you wanted to do it in parallel, it can do it in parallel again. Or you can say, wait until I've actually auto-remediated. And then after that, go and send a notification and integrate with my third-party existing tools. And again, in the flavor of keeping hands-off production instances, another really cool tool to use with Lambda is what we call Systems Manager, and the feature of that is run command. So run command actually gives you the ability to run a script on an EC2 instance without having to SSH into it. So this is really cool because you could have a set of kind of blessed scripts from your security team that are okay to run on those EC2 instances, and then you can use Lambda to actually call run command, execute that, and then using step functions, again, that will help you coordinate those Lambda functions, you can actually then go into a loop in order to wait for that command to finish, and then check on the output, and then take actions based on the output of that command. All right. So to kind of wrap up this event-driven section, there's a lot of different data sources that come in and a lot of different ways that you can utilize them. But the thing I want you to take away from this section is that CloudWatch has a lot of features that you can integrate AWS Lambda with, and there's a lot of different things because Lambda is just code. And so really the sky's the limit with AWS Lambda, and you can do many different things like detection, alerting, remediation, countermeasures, forensics, or security automation. And in the vein of security automation, we have today with us Sydney Sweeney, from Dow Jones, who's going to talk about how they're using Lambda to do security automation.
Thank you for the introduction, Brittany. A lot of that about CloudWatch and Lambda will be super important for what I'm going to take us through today. But I'd first like to start my section by talking about a video game that I've been playing a lot of in the last week. But I can't remember the name right now, so I hope you guys can help me. I think it rhymes with Fall of Duty, if anyone's heard of that. This game has a zombie mode, which is really fun. It starts off pretty easy. Your zombies are coming a few at a time. You're figuring out your map. You have doors and windows where the zombies can come in and attack you. And it gradually increases until suddenly a zombie is crawling up out of the floor, falling from the ceiling, or just sneaking up behind you and biting your arm off. Now, I was reminded a lot of a security problem. When you think about a security team trying to make sure their cloud environment is safe or their application is safe, they'll go through a really similar process by making sure that all of their doors and windows are secure from attacks, building up their defenses along the way by buying better guns and defenses for killing their zombies. So today I'll take you through how we automated the way we deploy our zombie defenses at Dow Jones. So imagine playing zombies, but on hundreds of maps at the same time. So Dow Jones is a part of News Corp, which is a global media company that comprises of business leaders in industries including book publishing, digital real estate services, paid TV distribution, sports programming, and news and information services, which you may recognize from some of the logos behind me, like Wall Street Journal and Barron's. Dow Jones is a tech leader in the News Corp family, and being so, we scaled our automation project across the News Corp business units. Redwood is the tool that we built to be able to scale our environment. This tool deploys our baseline security defenses across our AWS cloud environment. We needed something that could be centrally managed, have a small footprint, have minimal maintenance requirements, but most importantly, would be able to grow with our environment as it grows too. So this is what the Redwood architecture looks like in AWS services. The main compute is hosted on code build, which is actually a container that runs a Python process that executes Terraform to create the resources across all of our accounts. We use supporting infrastructure in DynamoDB to track all of our deployments and log them. And we store all of the resource configurations in a central S3 bucket so that every resource that's part of the scope of this project has its state somewhere that we can always check on it. We also store central CloudTrail logs, which is one of the controls that Redwood delivers to our accounts. Other controls include Cloud Health integration for billing optimization and visibility. Redwood also enables guard duty in all of the accounts in our organization. Redwood also deploys CloudWatch enforcement architecture to be able to detect configuration drift in our resources and react to them, and an Okta integration to federate all of our AWS accounts with SSO. Lambda plays a huge role in making Redwood more powerful by making it dynamic. Lambda gives us alternative trigger sources to be able to target our deployments to the accounts in our organization. The first example being to update and patch. We can use Lambda to isolate our process of talking to the organization's API to gather a full inventory of how many accounts are in our organization at a given point in time and coordinate parallel resource deployments to all of them. We can also use Lambda for a reactive enforcement infrastructure in the same way that Brittany presented. You can hook it up to a CloudWatch rule and have it triggered on a certain kind of event. And a good application of that for us is when we create a new account in our organization, we can automatically deploy security controls to that account as it comes up. This is the first example when we use Lambda to update and patch. When we isolate that process, and the Lambda can talk to the organization's API, which actually sits in the master account of our organization, and can describe all of the account IDs, our Lambda can extract the account IDs from that response and kick off simultaneous deployment processes in our code build as part of our Redwood system in our central cloud services account, where the system is hosted. And you can see the arrow again of how the flow works to create the resources in the child account that represent our security controls. And this is the generic mechanism for the reactive enforcement, where the CloudWatch rule will detect the kind of event that we should respond to. The Lambda can extract the account ID from that event and can target the deployment at that relevant account. This is what that looks like in the context of a new account. So when a new account is created with the organization service, that service will generate a CloudTrail event that says the account creation process successfully completed. And you'll have a CloudWatch rule that can detect that that happened and trigger a Lambda to validate all of your data is safe and good. Like you'll want to check that the account creation process was complete, the account ID is valid, and then you can kick off the deployment in the other account. This is what the whole infrastructure looks like on a single slide. You have supporting infrastructure in your master account, where the actual organization API creates the new account, and then you'll kick off your process in your central account and send the controls to the new account that just got created. And I actually have a video showing a demo of the end-to-end process of creating an account and seeing the new controls existing in it right away. So you have to enter a name for the account and an email. And I'm also going to create an access role to show how the master payer can access the new account as it gets created. We give it a particular name, which we'll come back to later. I'll take us to the CloudWatch rule that detects the event. This is what the sample event looks like. You should make sure that it's a service event from organizations itself, and that you have the success message to show that the account didn't fail on creation. The Lambda that gets triggered at the end of this rule will validate that the account creation was successful, and will also extract the account ID and take care of other logistics, like adding the new account ID to the central CloudTrail bucket so that the global trail can put to it, while also kicking off a deployment process in our central cloud services account. Have you ever recorded yourself using a trackpad? It kind of looks like you don't know how to use a mouse once you actually see it. So when you have a CloudWatch rule that's detecting an event, you can actually see on a graph how often it's invoked. So when I refresh the page, our new account event shows up as that blue dot. I'm actually now navigating to our central cloud services account so we can look at the log for the process that created the new resources. This is code build. And you can see that there were 2 successful code build executions in the last few minutes. And at the bottom, the Terraform log says 9 resources were added. We'll go now and validate that these are the resources that represent our security controls. Starting with our IAM resources, we created a Cloud Health role to allow for that integration to the account. We can see that the policy was successfully created and the sufficient permissions were granted to the Cloud Health platform. This is our IAM IDP type resource to allow Okta to do a SAML handshake into the account. We'll check that our global cloud trail got created and see that it's forwarding into our central bucket. And finally, we can see that guard duty was also turned on. And it's in the free trial because it was just enabled like a second ago. So it took 4 of us engineers part-time to kill our zombies over hundreds of AWS accounts. And I've actually provided a link for you to be able to get started too, if you're interested. There's an AWS blog that has some of the same principles as what we followed in this project for being totally serverless and microservice oriented, so that you can try it too. And now I'll introduce Andrew, who will talk about using Lambda in an enterprise setting.
All right, thank you very much, Sydney. Hey, everybody, my name's Andrew Baird. I'm a Principal Solutions Architect for AWS out of our Atlanta, Georgia office. I work with Brittany down in Atlanta. And I'm here to talk about some specific patterns that are good things to keep in mind when determining how you're going to utilize Lambda within your security organization across all the different accounts that likely make up your enterprise-wide usage of AWS. And Sydney and the Dow Jones team have a really mature platform that does a lot of great things like you saw. And I'm going to kind of boil down and distill what some of those patterns for the ways Lambda fits into those strategies so you can get an idea of where your organization can start its own path towards something like Redwood maybe someday. So the first pattern that I'm going to talk about, I'm going to call it extend. And what I'm referring to here is the ability for a Lambda function that's running within your security organization's AWS account to extend into all of the other AWS accounts that run as part of your enterprise and take actions of some kind. That can be to gather insights and describe instances and make sure they're configured the way you expect. It can be to take remediating actions, all sorts of things. But the idea is that you have code that you've written. That code runs within an account that you own. And that code is an extension of your policy and your security team into all of the other AWS accounts that are running inside of your enterprise. The best example, I think, of showing this in action is mirrors what Brittany's talked about already. That's through CloudWatch Events. And I'm going to highlight a specific feature that CloudWatch Events has that we haven't talked about yet that's relevant to multi-account organizations. That's called a CloudWatch Events bus. So CloudWatch Events for each of your accounts comes with a default bus for each of those accounts that's able to accept events that are occurring from other AWS services or also from events that are occurring across other AWS accounts that you've given permission to. So you're able to whitelist the accounts that are part of your organization. Maybe you're whitelisting them through similar automation like Sydney and the Dow Jones team have set up through Redwood. But every time an account's created, you'd add that account to your events bus whitelist. And then all of the events that you create in those accounts, they can be delivered as their target to an events bus that's sitting inside your security organization's account. and now you've got CloudWatch events that are occurring throughout the entire organization's account structure, but they're being delivered as events into an account that you own and you manage, and you can create your own triggering rules off of those events. So the way the architecture kind of looks is like this. All of those events that you'll provision into all those other accounts that you care about, as those events are firing and the activities that you filtered on are being detected, they're going to be delivered to that central CloudWatch events bus where you set up your own targets, potentially pointed at a Lambda function. And that Lambda function is able to, again, be an extension of your security team back into those accounts where the events are occurring. So those events could be to remediate the actions that have occurred that you think should not have taken place. It can be to gather more forensics or details, configuration details about the events that have occurred. And at the same time, that Lambda function can take other actions aside from what's happening in those accounts. It can integrate with your existing security tools. It can notify people if they need to be notified, things like that. So this is the extend pattern. The second pattern I'm going to talk about is centralize. So each of the models I'm talking about kind of operate under the assumption that your security team is operating its own AWS account and that you prefer to have all of your security policies and all the code that you're writing and all of your operational activities as a security team is going to be centralized within a single or set of AWS accounts that are separate from where your actual business applications are deployed and your developers to perform their duties for your organization. But the same kind of mindset could still apply if you're more single account oriented. So the pattern of centralize is to take all of the various forms of telemetry that AWS is generating across all of your accounts and make sure that telemetry is being retrieved and stored in a way and in a place that your security organization is able to have visibility into, whether it's to have that visibility or to make sure that all the telemetry is going to be unmodified and it's going to be secured and you've got access controls around it so that all of the accounts that are generating that telemetry and those developers and application teams that are free to continue behaving the way that they need to and having access that they need to for the resources that live within their accounts, that the telemetry you care about as a security team is still being delivered to a place that your application teams don't have access to, that your security team manages. And the way that Lambda can play a role in this type of pattern is either one, to help coordinate and configure those telemetry sources that you care about being enabled in those accounts, or it can act as a processing engine for the telemetry that's created. So as the new forms of telemetry are created, whether it be through CloudWatch logs or files being delivered into S3 buckets, those things can also act as event sources to Lambda functions that are running inside of your security account. And you can review and take action depending on all the details that are inside of those events that are being delivered. A great example of this in a multi-account organization of this centralized mindset is AWS Config, which we haven't talked about yet. For those that aren't familiar, AWS Config is all about being able to track the configuration changes for the resources across your AWS accounts and determine if those configuration changes that are occurring over time are considered compliant or not with whatever your compliance rules are. And the way that compliance is determined is by evaluating those changes against what are called config rules. And config rules can come in one of two flavors. Either they can be a managed rule where you can set some basic configuration information, and we've written a rule that will evaluate the change against your configuration and determine if a change is compliant or not. So an example would be we have a managed rule to make sure that no security group has SSH access open to the internet. You enable that rule. If a security group changes where that's observed, we will mark the security group as not compliant with that rule that you've configured. But the second flavor of config rules is a custom config rule, which is a Lambda function that you've written. And as those changes occur in your environment, the details and the configuration items that represent the resources will be delivered to the code that you've written. And the code that you write will be able to evaluate that change and determine your policy against the change that's occurred and determine if it's compliant or not. And the way this can kind of fit in a multi-account strategy is there's two great features, one of which is only about a week old. The first is called an AWS Config Aggregator. And what this gives you the ability to do is to provision all of those config rules within your security account within your organization, enable the delivery of the config changes from your application accounts to the config rule Lambda functions running in your account, And as you declare resources across those accounts as either compliant or not compliant, Config Aggregator gives you a centralized view of all of the different compliance statuses across all the different accounts within your organization. So you get a single pane of glass that gives you, visibility into all the different compliance state of all the resources that you've written config rules for. The second way that AWS Config plays really well with the multi-account strategy that's very new is rather than just having those compliance states be visible in a single pane of glass within one AWS account, you can actually now have all of the configuration items, they're called, the image that describes all of the resources within an account over some schedule. You can have that entire JSON object be delivered to a separate AWS account, which is likely your security account, and all of the changes themselves will be directly delivered to an S3 bucket or an SNS topic that's running within your security organization, and you can take actions or write Lambda functions against those things. Okay, so a lot of great options for Lambda to fit in, a lot of patterns. Two basic patterns, but a ton of possibility for the ways our services play into those patterns. And you might be thinking, okay, I get the idea that we're going to write code, it's going to run as functions. We've got a lot of accounts where things are going to be triggered and firing, but how do I manage that? There's a lot of complexity for my team, and there's a lot of accounts potentially that already exist within our organization. Where do I start provisioning the things I care about into those accounts in a way that's manageable and doesn't introduce a lot of heavy lifting and manual work? And Sydney and the Dow Jones team have really successfully implemented this with Redwood through a really cool use of our code build service. But another native functionality we have on AWS that's our native infrastructure as code service is called CloudFormation. If you're not familiar with CloudFormation, it gives you the ability to describe infrastructure resources and your environment details as code in either JSON or YAML, provide that description, that template, to an API, and have all the resources you've defined be programmatically provisioned into the account you've targeted. There's a functionality within CloudFormation that I think is crucial to understand as a security organization if you're adopting CloudFormation, and that's called stack sets. And what stack sets gives you the ability to do is to take a single template that you've defined that describes all those resources you care about, so potentially things like CloudWatch event rules, enabling CloudTrail, and I'm going to show you examples of these in a second in a demo, but define that single template you care about that defines the controls and policies you want to apply through code and resources, and target their provisioning into a number of different AWS accounts across different AWS regions. So from a single console, a single set of APIs, to take that template and provision the stack that you've defined into a set of AWS accounts where your applications are running across regions so that you have a single place to interface with programmatically and have all the things that you've written be provisioned across the entire organization. And it has native integration with AWS organizations as well. Each time you take an action with CloudFormation stack sets, when you're determining which accounts this template should be applied to, you can simply provide an organizational unit ID as part of our organization service, and every account that's part of that OU will have the template change be applied to it. So the stack will be created, the stack will be updated, those kind of things. So it's got this native integration with organizations that you might already be using and organizing your accounts through AWS orgs, and stack sets plays really nicely with it already. So I'm going to pause there and do a brief demo of a couple different ways these patterns can be applied in an actual AWS account and show you some code. So I'm going to pop out here. And what I have here, and this is as large as I think I really need to make it. This is a full CloudFormation template. This is a template, and if you're quick, you could probably type this template down on your own keyboard while I've got it on here. And if you're watching on YouTube, you can just pause now and take a look at the code. And we're back. Okay, and this is just enabling CloudTrail. It's going to enable CloudTrail. It's going to make sure that all the global resources are tracked, like IAM. You want CloudTrail enabled in all AWS regions. Very simple template that, when applied, will enable CloudTrail across all of your regions for an account. So this is great for that gather or centralized pattern, where I've listed a single S3 bucket name that's living inside a central security account I've got created as part of organizations. And every time this template runs, this CloudTrail and all of its log files will be delivered to this one S3 bucket that I've created that sits in my security account. So a centralized example. a second CloudFormation template I have here is more of the extend model, where I've created a CloudWatch event rule that I would like to be provisioned in my application accounts anytime a EC2 instance is pending. So if someone's just launched an EC2 instance, it hasn't started yet, it's in pending state, and I'd like this rule to be triggered every time that occurs. The two other resources, just two, that are also being provisioned at the same time are pretty critical and an interesting part of what you're provisioning into other AWS accounts as a central security account. And these are IAM roles, an IAM role and an IAM policy that's going to grant my security account the ability to assume a role into this account where it's been provisioned. So you can see I've got a trust policy set up, and you would probably not hard code things in here. You might, add this as a parameter and parameterize it, but for the sake of the demo, I just have my account ID hard coded in here. And this is going to create a role in every account it's provisioned into that gives my account the ability to assume a role into it and take actions. And the policy that I have is the ability to interact with the EC2 service and to call describe instances to gather detail about the instance that was just created, and if I would like to terminate that instance. So I now have a CloudWatch event that will detect every time an instance is started, and I have the IAM resources required to let my account assume a role into this account and swat things down as required as my policy dictates. So pretty small amounts of YAML code here that is going to enable both of those types of patterns in pretty interesting ways. So I'm going to pop over to the AWS console here and kind of show you in action. First, I'll kind of show you the CloudFormation stack sets console to give you an idea of how neatly this is laid out. So I have these two stacks. I've already pre-provisioned them for the demo into all of the accounts as part of my organization. We can take a look at the pending EC2 instance CloudWatch event rule. And it gives me an immediate view of the times it's been deployed and all of the accounts that this stack has been applied to and what their state is against the current version of the template. So it will tell me that all of the accounts in my org that this template's been pushed to, they've got the current version of the template. If I add an additional AWS account to this stack set that I haven't pushed the most updated version of the template to, it'll tell me it's outdated here on the screen. But all of my accounts are current right now. So based on those two things I've implemented, and I'll show the Lambda coder in a second that's taking actions, I've got the ability to go in from my central security account. I'm going to federate through a separate role just for the demo into an application account, and I'm going to launch an EC2 instance. So the EC2 instance AMI, or the image ID, that I as a security team have whitelisted is I want my team to only use Amazon Linux 2. I care about long-term support. I want to make sure that's enabled. I've got bootstrapping capabilities built in for Linux 2. And if somebody launches any other AMI, I want that instance to be terminated. So I, as an application team, maybe I'm unaware of this, maybe not. I've decided that there's a different AMI that I prefer, and I don't care what the security team thinks about it. So I'm just going to go ahead and launch it. So we're going to pick a separate AMI. We're going to proceed without a key pair just for the sake of the demo, and I'm going to launch the instance. If I take a look in my EC2 console now, just because it took me a couple seconds to click on View Instances, you can see it's already shutting down. It was in pending state for maybe a couple seconds before that CloudWatch event rule was triggered, notified my security account that has role-based access into this account, and a Lambda function I wrote took action to terminate the instance. So very immediate. This is a piece of infrastructure that wasn't even allowed to stand up before the security team took action against it. So I'll jump back into my admin account and give you a brief look at kind of how the Lambda function code is written. So let me refresh here. So I've got two separate Lambda functions. There's this function is what's relevant to the conversation right now, to inspect EC2 changes within my account. So I'll blow up the code here. And not a lot of code, just take away the white space, maybe 30 lines of Python code, and I'll briefly describe what's happening here. So as events are occurring that match that rule, I have a hard-coded, you wouldn't hard-code this in the real world, but I have a hard-coded AMI ID. You'd probably store this as dynamic configuration within S3 or DynamoDB. This is the AMI whitelist. For our purposes, it's a simple list with a hard-coded string. The first thing that our code's going to do, it's going to extract the instance ID as part of that event. CloudWatch gives me that instance ID as part of the event. I'm going to extract it, and then I'm going to use the STS service to call the security token service to call its API assume role. And I'm going to call assume role with, again, another hard-coded parameter you probably wouldn't hard-code in your code. But that's going to assume the role I created as part of that CloudFormation stack. So now my Lambda function's assuming the role that was pre-created alongside the event that triggered this function. And I'll immediately, from its response, grab AWS credentials. So I've now got temporary AWS credentials for that role. And I'll create an EC2 client using those credentials here. And once I've got an EC2 client created, I'm going to call describe instances and gather all of the details about the instance that was just created. I'm going to have a little if statement here. If the instance is part of my AMI whitelist, and that's the image ID it used, I don't need to do anything. Everybody's following the rules. But if they launch something I've said that they can't launch, I'm going to take action immediately. My code is going to extend my policy, programmatically terminate with prejudice that EC2 instance that doesn't follow our policy. So you can see here I call that same EC2 client using my temporary credentials, and I'm going to terminate the instance, and it was shut down before it could even stand up. So a great example of that, extend pattern of extending your policy through code into your AWS accounts. Now, the second piece I'm going to show is the more centralized model. Let's go back here, scroll up. Let's go like this. So I have a second Lambda function that's going to take all the CloudTrail logs that are delivered to my S3 bucket centrally, but I want to operationalize them a little more. And there's cross-account delivery of CloudTrail logs to S3 buckets, but I want to take the logs that are delivered to S3 and put them somewhere more useful to me as an operations security team. So I've written a small Lambda function to be triggered every time a new object lands in that S3 bucket as part of the CloudTrail trail. And what this code is going to do is it's going to evaluate the specific object that's landed in the S3 bucket. So there's a new file that's landed in the bucket. I'm going to gather metadata about, what's the bucket name, what's the object key. I'm going to call getObject to download the object locally. I'm going to do some, decompression and encoding things that are just, relevant to the way the files are created by CloudTrail. And then I'm immediately going to interface with our Kinesis Firehose service. And I'm going to take the data I've extracted from the S3 bucket, and I'm going to use this little lightweight Lambda function to flip that same file over to our Kinesis Firehose service, which is a real-time data ingestion service. And the destinations for Kinesis Firehose can either be another S3 bucket, which wouldn't be too useful for me right now, but for a lot of cases it's very useful. Or you can also have the destination be a Redshift cluster for a data warehouse, an Elasticsearch cluster, or Splunk. And those are all native integrations from Kinesis Firehose. So for my Kinesis Firehose, I deliver all of my CloudTrail log information to Elasticsearch. And AWS Elasticsearch has a Kibana built in. And I've got a Kibana dashboard here that I've federated into, and I can log in. And I immediately have all of my CloudTrail data that's been delivered to S3 through that CloudFormation stack set. My small Lambda function's taking those files, flipping them to Kinesis Firehose, and now I have a near real-time visibility into that CloudTrail information in a very operationally savvy service like Kibana on top of Elasticsearch. So you can see examples here where if I pull out the amount of data that I'm looking at, that in the last 24 hours I've had one terminate instance occurrence occur. And then you can take advantage of all the Kibana features. It's not a Kibana session necessarily, but it's a great tool with a lot of operational log visibility and searching and indexing. But 30 lines of Lambda code and some CloudFormation, 10 lines of CloudFormation, I have all my CloudTrail data in a central security account sitting in a very searchable index service like this. So that's the centralized pattern. So Lambda provides you with that very flexible compute service where the business logic that you want to apply as a security team and business logic in terms of policy and enforcement and remediation and those things can sit very neatly between all of these services we provide that create telemetry or provide events, and they can take action for your security team. So with that, I'm going to jump back into the demo. And aside from those two patterns, I want to highlight one more pattern. I'm going to call it pattern 0. And many people probably have heard of the design principle of KISS. I'm going to replace simple with SOA, or service-oriented architectures, because they've been a foundational pattern for software architectures for years now, and Lambda plays really well within those designs too. So you can wrap a Amazon API Gateway REST API endpoint around a Lambda function, and now you've written an HTTP microservice where the code that you've written is sitting behind an API that's being managed in a serverless way. And you as a security team can do all sorts of things now that you've got security code sitting behind an API. You can build custom security dashboards or web applications that do interesting things that you'd like visibility into. There's all sorts of chatbot type platforms and services that have the concept of webhooks that can reach out to HTTP APIs. And those webhooks can be processed by a Lambda function that you've written. So imagine typing a Slack command or having a GitHub commit through a webhook, trigger an API call to code that you've written that's going to evaluate whatever that chat command is that you've run in Slack, or evaluate the commit that's just occurred in GitHub or something like that. And the third thing is just general integration. There's a lot of third-party tools you may be already using, and maybe they even predate Lambda as a service, but they have the notion of APIs, and they can integrate with things through HTTP. And using API Gateway as a front door for Lambda functions gives you the ability to build any amounts of software that you'd like, and to do the things you like, and have your existing tools through their API capabilities integrate with logic that you've written as part of your Lambda functions. So this is pattern 0. There's going to be a lot of ways where you can think service-oriented, and Lambda is a great fit to run lean code, minimal operations as a security team, and have those service-oriented integrations. The last thing I'm going to conclude with is just some things and thoughts to caution you about. If you're a team that's thinking about adopting Lambda as a security team for the first time, these are some cautionary examples, some anti-patterns, things for you to be aware of. So the first one is be aware of alarm fatigue. There's a lot of events that can be triggering in an AWS account. Be very specific about which events you care about and what's going to happen when those events occur. You don't want to write a Lambda function that's going to be triggered every time a security group changes and have that action be like to deliver an email into an inbox somewhere that you've got an email about a security group changing. It's just going to be a boy who cried wolf situation. No one's going to look at those things. So be very intentional about what rules you care about. Second is similar. Be aware that as you write the code that's going to deliver alarm alerts or take remediating action, notify things, that there's a next step if one's required, that there's going to be accountability or action that needs to be taken either by your team or by application teams. Don't just write security code within Lambda functions that spends time evaluating the lack of security within your environment so that you guys are covered from a standpoint if something occurs. There's got to be actionable steps that you've defined if you have any findings that your Lambda functions detect. Don't think too exhaustive about the way you're going to build out your platform. Redwood is a very impressive piece of architecture that Dow Jones has built, but Lambda is it enables a lot of iterative thinking. You can start really, really small. Don't try and build something like Redwood as your first foray into serverless. Think about a Lambda function that's small and useful, and learn about your capabilities for running the service and get familiar with it, and think small and start iterative. The next I will highlight is the idea of preferring tools over purpose. So you as a security org have the purpose of keeping your organization safe, keeping your data and your customers' data secure and safe. And oftentimes, the security apparatus that you're working with today may not be an exact fit for the things you'd like to do with Lambda. And we want to caution you about having a preference to make sure all the actions you want to take and the security that you'd like to provide within the account has to play with the tools you're already using. If the real purpose for your team is to raise the bar for security and make sure the account infrastructure is safe, and there's something about your existing tool set that's preventing you from being flexible and agile and using things like programmatic approaches in Lambda, think about ways that you can have both at once, that you can still enable use of serverless and Lambda, even though your existing tools might not play well with events that may be occurring by the hundreds every minute, or the scale with which data is created may exceed the data you're able to ingest in another tool. Think creatively about other architectures and how to work around those things. And the final one, and probably the most important for security organizations, if you don't have development resources within the security organization already, that is the #1 thing I'm going to recommend you start looking into. It is a total anti-pattern in my view to have code that exists within an account that you're responsible for as a security team, that your team isn't responsible for, that the code wasn't written by somebody on your team if there's a need to maintain it, that you depend on somebody else's priorities and resources for. So it's absolutely critical if you want to start a foray into automated security and building out your own programmatic actions, to have the responsibility for creating that code and maintaining that code live within the security org so that your priorities are your own, and when there's a need to take action or write new code or maintain it, that you don't have a dependency on anybody else. All right, and with that, I'm going to conclude just a reminder of all the benefits that embracing Lambda is going to bring to your security team. So you're going to be able to embrace automation. You're going to be event-driven rather than policy and manual process-driven. It's going to let you scale without introducing immense complexity across potentially hundreds or thousands of AWS accounts when you start thinking about infrastructure as code and being programmatic with Lambda. We know that security teams often run very, very lean. Resourcing is tight. And Lambda is the best model, we think, to minimize operations while introducing the custom application code that you like to in the environment. You're not going to take on a big burden of patching and operational maintenance and things like that when you embrace Lambda. It's going to reduce costs, let you remain flexible. And finally, once you have Lambda functions that act as a security extension of your team, hopefully, security team members will be able to not just get some good sleep at night, but you can take some vacations too. And we've got our security team riding the SS threat vector, their CISO's yacht, on vacation because Lambda is watching the environment while everybody's on vacation now. So thank you very much, everybody. Please do remember to fill out your surveys. Thank you for attending. Hope everybody's enjoying their week. And enjoy the rest of your sessions today.